As you see here, we have two if conditions in the main function. The first if condition is responsible for checking if the root value is null. The second if condition is responsible for checking if the current node is a leaf node. So if the current node is a leaf node, what we do is we check if the leaf node that we have visited is the first leaf node. That is what if head equal to null means. If that is the case, we assign the head pointer to this leaf node, and using this leaf node, we'll be able to access the entire doubly linked list further. And if this leaf node is not the first visited leaf node, we assign a previous pointer to the previous leaf node, and we connect the current leaf node, which is the root dot left, and we connect the previous leaf node using the pre variable, and we form a doubly linked list. And after forming a doubly linked list, we assign the value of prev to the current leaf node. That is what prev is equal to root means. And after doing the above process, we will be returning a null value. The reason we return a null value is we have to ensure that the leaf node is not connected to the parent node further. So that is why we return a null value to this a null value in this if condition. So we'll now take this binary tree and extract all the leaves of the binary tree into a doubly linked list. So as we see in the code starts from the root node, and it checks that neither the left and nor the right subtree are null. That is, the root node is not the leaf node. So we go to the left subtree of root 10. At 11, we again check if the 11.left and 11.right are null. Since that's not the case, we go to the right subtree of left subtree of root 11, which is 14. At 14, the first if condition, that is the second if condition, which is root dot left equal to null and root dot right equal to null, are satisfied. So this node is the real leaf node, and within the if condition, the head is null, so this node will be considered as the head. So head is equal to 14 and previous is equal to 14. So what the head basically tells is this node will be the first node of the doubly linked list that we are going to form, and we will be returning a null value back to 11. At 11, what happens is root dot left becomes null. So this basically means 11, which used to have 14 in the left subtree, will now be containing null value. So that is what this means here. Again, we go to the right subtree of 11. At 17, we check if 17 is the leaf node. Since that is not the case, we go to the left subtree of 17, and at 20, we come to know that root dot left equal to null and root dot right equal to null. So at 20, we check what's happening inside the if condition. That is, head is not null. There is already a leaf node present. So prev dot right is equal to root and root dot left is equal to prev. So what this basically means is the right pointer of 14 will now be pointing to 20, and the left pointer of 14. So what happens at node 20 is, since head is not null, we go to the second else condition inside the statement. So prev dot right, that is prev is already pointing to 14. The right pointer of 14 will now be pointing to root, and root dot left is prev. That is, the left pointer of 20 will be pointing to 14, and now previous becomes root. So previous is equal to 20 now. Now what happens is we return a null value back to 17. So at 17 we get root dot left is equal to null. Root dot left is equal to null. So the relationship between 17 and 20 is over. So 70 will now only be having 21. Now 17 goes to the right subtree of its own right subtree and checks if there are any leaf nodes. At 21, the second if condition, if condition is satisfied, that is, left and right are both of them are null, and since 21 has only the head value is not null here, and the previous is 20, we have prev dot right, that is 20 dot right is equal to root. So the right pointer of 20 will now be pointing to 21, and root dot left is equal to prev, that is, the left pointer of 21 will be pointing to 20, and previous is equal to root. Now previous will become 21, and will again return a null value to 17. So what happens at 17 is root dot we again go to 17, and root dot right is also null. Now at 17, we return the root value, that is the root address of 17, back to 11. At 11, the tree that is present will be 11, this is null, and 17, and both of them are null. So this is how the tree will look like when it's at 11. and the control will now go over to the left subtree to the parent node of 11, which is at root 10. So root 10 will now pass the control to the right subtree of 10 of its own right subtree, which is 12. We see if we then go to 12 and see if it is a leaf node. Since that is not the case, we go to its left subtree, that is 18. At 18, we check the 18 is a leaf subtree or is a leaf node. So we check the head pointer and we see that there is already a head present. So the previous, that was 21, the right pointer of previous, which is 21. So the right pointer of previous, which is 21, will now be pointing to 18, and the left pointer of 18, which is left pointer of 18, will now be pointing to previous. So, and the value of previous now becomes 18. So the linked list, the doubly linked list that we are having will look like 14, 20, 21 and 18 so far, and the value of previous is 18 and previous returns a null value back to 12. So at 12 we have root dot left as null. That is, the relationship between 12 and 18 is over right now, and 12 now goes to the right subtree of its own right subtree, 19, and we check it 19 if this is a leaf node. Since that is not the case, we go to the leaf tree to the left subtree of 19. At 25 we again check that 25 is a leaf node. So the value of previous is now 18, and the value of previous does is, we take the left pointer of 25 and point it to 18, and the root dot and the previous dot right value will be pointing to the root value, that is 18. The left pointer of 18 is already pointing to 21 in the roots in the BST, in the doubly linked list. And what happens at 25 is, the prev dot right value, that is the right pointer of 18 will now be pointing to 25, and the left pointer of 25 will now be pointing to 18. So that is what is happening here. So, and the value of previous at 25 now becomes 25, and we return a null value back to 19. So at 19, the root dot left value, and we go back to 19 and the root dot left value is null. We now go back to 27. We now go to the right subtree of 19 and see if there are any leaf nodes. So at 27, what is happening is, 27 is a leaf node and the value of previous is 25. So the value of previous dot right, that is this 25 is right pointer, will now be pointing to 27. It is 25 is right pointer will now be pointing to 27, and 27's left pointer, that is root dot left pointer, will now be pointing to 25, and the value of previous also becomes 27, and we return a null value back to 19. This is how the connection is done. This is the left pointer of 25, and the right pointer will now be pointing to 27, and the left pointer of 27 will now be pointing to 25, and the control goes back to 19, and at 19 we return the root value back to 12. So at 12, the subtree will be 12, null, 19, null and null. I am representing null as n, and so that is what is happening here. And 12 will also return its root address back to 10. So at 10, what is going to happen is 10, 11, 12, and at 11 we have null, 17, null, null, 12, null, 19, null, null. So every single leaf node returned a null address back to its parent. So which means there are no more any leaf nodes present, and all the leaf nodes have now been converted into a doubly linked list as you see here. So the final doubly linked list will be 14, 20, 21, 18, 25 and 27. So on the head pointer, as we saw in the first iteration, will be 14. So you can use this head pointer to traverse the entire doubly linked list by doing head dot right, and by iteratively going through the entire linked list, entire doubly linked list. So this is how we extract all the leaves into a doubly linked list. Thank you.